Okay, so today we've got a fascinating story for you from the world of AI. It's a real David versus Goliath tale, where a tiny new model is going up against the absolute giants of the industry. And, well, you'll see what happens. You know, we're always told that in the AI arms race, bigger is always better, right? More data, more power, billions and billions of parameters, that's how you build the best models. But what if that's not the whole story? What if, for some of the really tough problems, the answer isn't to get bigger, but to actually get smarter? Look, today's big AI models, these large language models, they're amazing, no doubt. They can write you a poem, they can fix your code, they can plan your next vacation, but here's the wild part. When you put them up against certain types of reasoning puzzles, like a really hard Sudoku, these giants with hundreds of billions of parameters, they can fail. And not just fail, they fail spectacularly.
All right, so let's set the scene. Think of it like an arena, one designed to test the absolute limits of pure reasoning with some brutally difficult puzzles. This is where the Goliaths of the AI world come to play. And, as it turns out, it's where their biggest weaknesses get exposed.
And just look at this. This is what's so wild. Take a look at the big guys. DeepSeek, with a staggering 671 billion parameters. What's its score on this super tough Sudoku test? 0. A big fat 0. Same for Claude 3.7. They literally could not solve a single one. Now that kind of failure, it just cracks the door open for a totally new way of thinking. And as you can see, two much smaller models decided to step into the ring.
Okay, so let's meet our first contender. It's called the Hierarchical Reasoning Model, or HRM for short. This was one of the first big attempts to tackle these puzzles with a smaller, more specialized design. But its strategy, well, it was anything but simple.
So, the first key idea here is something called recursive hierarchical reasoning. The easiest way to think about it is like having two little brains working together. One brain thinks really fast, handling the low-level details, while the other one thinks slower, more deliberately, at a high level. The model keeps passing information back and forth between them, hoping that this kind of complex, biologically inspired dance will eventually lead to the right answer.
And then there's a second trick, something called deep supervision. Basically, instead of trying to get the answer right in one single shot, the model gets to improve its own guess over and over again, up to 16 times. It's like letting the AI check its own homework, learning a little bit more with each pass.
Now, this is where it gets a little complicated, but stick with me because this part is super important. A single thought for HRM involves this whole 6-step process, but look closely. It only actually learns anything new in the last 2 steps. The first 4 steps, it's just going through the motions. That should be a little red flag, right? It hints that maybe something here isn't quite as efficient as it could be. And yeah, that little red flag points to some pretty big problems. HRM was a decent first try, for sure, but it was kind of built on shaky ground. It was using this mathematical shortcut that probably wasn't even valid, its training was super inefficient, and you know what? The whole thing was just way too complicated. There had to be a better way. And that's when our underdog enters the story, the Tiny Recursive Model, or TRM. Instead of trying to add more complexity, its creators did the exact opposite. They started stripping everything away, betting big on a radical idea. Less is more.
Okay, so the first thing they did, they tossed out that sketchy math shortcut. Instead of only learning from the very end of the process, TRM learns from its entire chain of thought, from beginning to end. And that one change, wow, it turned out to be a total game changer. But they didn't stop there. Remember HRM's 2 separate brains? Gone. TRM uses just one single network. And get this, they even cut the number of layers in that network in half, from 4 down to just 2. I mean, that is just radical simplification.
And finally, they made it way more efficient. HRM's training needed 2 full passes of the model for every single little tweak. TRM streamlines this, cutting the cost of training in half. So it's not just more accurate, it's also cheaper and faster to get it up and running.
So, after all that stripping away, all that simplifying, what are we left with? A model with just 7 million parameters. 7! That is, it's almost nothing. It's more than 3 times smaller than the already small HRM, and it's less than 0.01% the size of the giant models it's up against. It's almost unbelievably tiny.
All right, the stage is set. We've got our complex challenger and our tiny little underdog. It is time to see who won the fight. Let's look at the data. Just look at that. On the Sudoku-Extreme test,
HRM scored a respectable 55%, not bad. But TRM, our tiny, simplified model, scored an incredible 87.4%. That is a massive, massive leap in performance, and they got there by doing less, not more.
And this wasn't some fluke. Look across the board here. On maze solving, it jumped from about 74% to over 85%. On the really tough ARC-AGI reasoning test, it took the lead there too. In every single category, the smaller, simpler model absolutely dominated. It wasn't even close.
So you have to be asking, how is this even possible? I mean, the researchers themselves were pretty surprised. They think the giant models were likely overfitting. With only 1,000 examples to train on, the big networks basically memorized the answers instead of learning the underlying rules. They were just too big and powerful. The tiny TRM, on the other hand, was too small to overfit, which forced it to actually learn how to reason.
So look, this isn't just a fun little story about the little AI that could. The fact that less is more won the day has some huge implications for where AI development might be heading next.
And this really is the core takeaway. Brute force scaling isn't the only answer. For complex reasoning tasks, it turns out that a small model that thinks recursively, that reasons and refines and improves its own thoughts, can achieve things that a massive model just can't.
Which leaves us with a pretty fascinating question for the future, doesn't it? As we continue to build artificial intelligence, is the next great leap going to come from building ever larger digital brains? Or is it going to come from designing smaller, more elegant systems that have truly learned how to think?